नमस्कार दोस्तों, मैं शिवानंद उपाध्याय आपका स्वागत करता हूं हमारे YouTube चैनल केमिस्ट्री एकेडमी फॉर IIT JEE and NEET. Since JEE mains exam will be soon, keeping that in mind, today we are going to discuss disproportionation reaction. We'll discuss following things in this video: balancing of disproportionation reaction, calculating equivalent weight of chemical species undergoing disproportionation. We'll also cover all the examples of disproportionation reaction given in NCERT along with the questions given in NCERT. So let us start with the definition of disproportionation reaction. There are few points given here about disproportionation reaction. We read it one by one. Disproportionation reaction is also known as auto-redox reaction. Same element in a chemical species undergoing oxidation and reduction simultaneously. The same element exists in at least 3 different oxidation states. Examples of disproportionation reactions, we are covering those examples which is given in NCERT. So the first example is disproportionation of hydrogen peroxide in aqueous medium. The second example is disproportionation of white phosphorus in basic medium. The third example is disproportionation of sulfur in basic medium. The fourth example is disproportionation of halogens in basic medium. And the fifth example is disproportionation of cyanogen gas in basic medium, and the last example is disproportionation of manganese plus 3 ion in acidic medium. So the first thing about these reaction is we should know what are the products formed on disproportionation. Like in case of H2O2, in aqueous medium it will disproportionate to form H2O liquid and O2 gas. Since these examples are given in NCERT, so we should know what are the products formed on disproportionation. Same way for the second example, disproportionation of white phosphorus. White phosphorus on disproportionation will form phosphine gas and sodium hypophosphite or hypophosphite ion. The third example is on disproportionation of sulfur in basic medium. There is formation of sodium sulfide or sulfide ion and sodium thiosulfate or thiosulfate ion. On disproportionation of halogen in basic medium, except fluorine, chlorine, bromine, iodine goes to disproportionation in basic medium. Like chlorine on disproportionation will form Cl minus ion and OCl minus ion, chloride ion and hypochlorite ion. Similarly, disproportionation of cyanogen gas in basic medium will form cyanide ion, Cn minus ion and OCn minus ion, cyanate ion. And Mn plus 3 ion on disproportionation in acidic medium is converted into Mn2 plus ion and MnO2 solid. So let us start with the first example, disproportionation of hydrogen peroxide in acidic medium. Most of you know this reaction. This reaction is also in kinetics. H2O2 follows first order kinetics. So whenever we have to balance a chemical reaction, we should follow 3 steps. First we have to balance those atoms whose oxidation or reduction is taking place. Then we'll balance the charge, and then we'll balance those atoms whose oxidation and reduction is not taking place. So for this reaction we can see here that the same element in H2O2, that is oxygen element, is in -1 oxidation state and it is converted into H2O. So oxygen from -1 is going to -2 and O2 means oxygen is going to 0 oxidation state. So in H2O2, oxygen is the element which is undergoing disproportionation because it is existing in 3 different oxidation state: -1, -2 and 0. So let us start balancing the oxidation part, and since the medium is not given, we can take acidic medium or basic medium, or sometimes if acidic or basic medium is not there, it will cancel out, indicating it is a neutral medium. H2O2 in aqueous state, when it is undergoing oxidation, oxygen from -1 oxidation state is converted into 0 oxidation state, so it is converted into O2 in gaseous state. First we are going to balance the atoms whose oxidation number is changing. So on the left hand side, oxygen atoms are 2, on the right hand side oxygen atoms are 2. Oxygen from -1 is going to 0 by loss of 2 electrons. We can write here 2 electrons. If we are taking acidic medium to balance the charge, on the right hand side, in order to balance the charge, we can write 2 times of H plus ion. Now we have to balance the atoms whose oxidation number is not changing. Hydrogen atom oxidation number is not changing. On the right hand side it is 2, on the left hand side also it is 2. This oxidation reaction is balanced. Same way we'll balance the reduction reactions. In case of reduction reaction, we can write that H2O2 in aqueous state will accept 2 electrons because oxygen from -1 is moving to -2. There are 2 oxygen atoms in H2O2, so we can write here that it is converted into H2O in liquid state. Since on the left hand side there are 2 oxygen atoms, so here we'll multiply by 2. We have taken acidic medium to balance the charge, so 2 times of H plus ion. So the second step is done, that charge is balanced. Now we'll count those atoms whose oxidation number is not changing. So hydrogen is the atom whose oxidation number is not changing. Hydrogen on the left hand side, 4 on the right hand side, 4. The reduction part is also balanced. Now we have to balance the overall reaction. So we know that in redox reaction, one chemical species will give electron and the other chemical species will accept electron. So in both the reactions, the number of electrons are equal. So if we add these two reactions, half cell reactions, the electrons will cancel out. 2 times of H plus will cancel out. So on the left hand side, we can write that 2 times of H2O2 in aqueous state. In aqueous state will disproportionate to form 2 times of H2O in liquid state plus O2 in gaseous state. So this is the balanced reaction. We already know that in order to balance a chemical reaction, redox chemical reaction, first we balance those atoms whose oxidation number is changing, then we'll balance the charge, and then we'll balance those atoms whose oxidation number is not changing. Now coming to the second point, equivalent weight of H2O2. So when we are discussing equivalent weight, in case of intermolecular redox reaction, we are saying that equivalent mass is the mass involved when 1 Faraday charge is participating corresponding to a chemical species. Like here, there are 2 methods to calculate the equivalent weight of H2O2, because here H2O2 is participating in oxidation as well as reduction. So we can use the first method to calculate the equivalent weight, and according to first method we'll find the N factor as the number of electrons participating corresponding to 1 mole of that chemical species. So here H2O2 is going oxidation as well as reduction. So H2O2 is the chemical species. In the balance reaction, 2 electrons are participating and 2 moles of H2O2 is also participating. So we can say that according to method 1, for 2 molecules, 2 electrons are involved. So we can say that for 1 molecule in overall reaction, 1 electron is involved. So we can say that the X factor or N factor of H2O2 in this chemical reaction is equal to 1. From there we can say that equivalent weight is equal to molecular mass or molar mass divided by N factor or X factor, which is equal to 1. There is a second method. Since H2O2 is participating in oxidation as well as reduction simultaneously, so what we are going to do that, we'll find out the equivalent weight of the H2O2 which is participating in oxidation reaction, and we'll find out the equivalent weight of H2O2 which is participating in reduction reaction simultaneously, and for the overall H2O2 we'll add the equivalent weight of H2O2 participating in oxidation and reduction. So here in method 2 what we are doing, that in oxidation H2O2 is converted into O2 by loss of 2 electron, oxidation reaction. So we can say that 1 molecule of H2O2 is releasing 2 electrons. So equivalent weight is equal to, in oxidation reaction, equivalent weight is equal to molar mass divided by 2. So this is for oxidation part. For reduction part we will calculate the equivalent weight. So again in reduction part, H2O2 is converted into H2O by accepting 2 electrons. So again here for reduction reaction, H2O2 is accepting 2 electrons. So we can say that 1 molecule is accepting 2 electrons. So equivalent weight is equal to molecular weight divided by 2. This is for reduction part. And if we add the equivalent weight of H2O2 participating in oxidation as well as reduction, will get the equivalent weight of overall H2O2. So here when we are talking about what is the net equivalent weight of H2O2, then we can write that this is equal to molar mass divided by 2 plus molar mass divided by 2. So we are going to get molar mass divided by 1. So X factor is 1. So either we'll solve or calculate the equivalent weight by the first method or the second method, we are getting the same answer. When H2O2 is undergoing oxidation or H2O2 is undergoing reduction, because H2O2 is a very good oxidizing agent as well as reducing agent. So when H2O2 is oxidizing agent, it is converted to H2O, and here one molecule of H2O2 when converted to H2O will accept 2 electrons. So its X factor will be 2, or equivalent weight will be molecular weight divided by 2. Same way, when H2O2 is acting like a reducing agent, it itself converted into O2. So H2O2 by loss of 2 electron, it is converted into O2. So one molecule is losing 2 electrons. So the X factor of H2O2 when it is acting like a reducing agent will be 2. So it should be clear that in disproportionation reaction X factor is 1, but most of the time H2O2 is acting like oxidizing agent and reducing agent where its X factor is 2. So let us discuss a question of NCERT. This is a very important question. They have given a reaction between ozone and H2O2, and the product is given H2O in liquid state and oxygen 2 times of O2. They are saying that why it is more appropriate to write this reaction as O3 gas plus H2O2 liquid will form H2O liquid plus O2 gas plus O2 gas. So this is the difference. Let us discuss this concept. So very simple concept. We know that ozone is a very good oxidizing agent, and here they have not mentioned the medium, so we can take acidic medium. In acidic medium, when H2O2 here, because ozone is oxidizing agent, means H2O2 is reducing agent. So when H2O2 is reducing agent, it is itself going to oxidize. So when H2O2 will oxidize, it is converted into O2 gas. So here oxygen atoms on the left hand side is 2, on the right hand side is 2. There is loss of 2 electrons, and in order to balance the charge, we should write in acidic medium 2 times of H plus ion in aqueous state. So this is the balance reaction. So this is oxidation reaction. Now ozone is the oxidizing agent and ozone is unstable. It will provide O2 gas plus nascent oxygen. So this nascent oxygen in ozone will accept 2 electrons. If the medium is basic, it will exist in the form of OH minus. When the medium is acidic, it will exist in the form of H2O. So here when ozone is acting like an oxidizing agent, ozone is a very good oxidizing agent, so it itself decomposed to give O2 gas. So this O2 is not participating in redox, but the nascent oxygen will accept 2 electrons to convert it into H2O in acidic medium. If medium is basic, we can say that this oxide ion is existing in the form of OH minus, but since it is acidic, it will convert into H2O. So now we can balance the reaction. Medium is acidic, so in order to balance the charge, we should write here 2 times of H plus ion. So on the left hand side, oxygen atoms are 3. There are 2 oxygen atoms which is not participating in the redox. Only 1 oxygen atom from nascent oxygen is going to -2 oxidation state by taking 2 electrons. Hydrogen atom on the left hand side and right hand side is balanced. So overall reaction is balanced. Now if I add these two reactions, we can see that the number of electrons participating in these two reactions are equal. They will cancel out. H plus ion is cancel out. So we can write that H2O2 in liquid state plus ozone in gaseous state will form H2O in liquid state plus O2 in gaseous state plus O2 in gaseous state. So while writing in this term, we are able to find out that one molecule of oxygen is obtained from H2O2 and one molecule of oxygen is obtained from ozone. So that's why it is appropriate to write like this. Let us start with our second example, balancing of disproportionation of white phosphorus in basic medium. So here when white phosphorus is converted into phosphine gas and hypophosphite ion is an anion obtained from hypophosphorus acid. Since acid is there, so the name of anion will end with ITE. That's why its name is hypophosphite ion. Here the oxidation state on the left hand side of phosphorus is 0. On the right hand side in phosphine, the phosphorus is in -3, and in hypophosphite ion the phosphorus is present in +1 oxidation state. First we'll balance the oxidation reactions. Phosphorus, we can write P4 in solid state is converted into, in oxidation oxygen, it is converted into hypophosphite ion, so H2PO2 minus ion. First we balance those atoms whose oxidation number is changing. On the left hand side 4 phosphorus atoms are there, that's why we'll multiply right hand side by 4. Now we should write how many electrons are participating in this. Phosphorus from 0 is going to plus 1. One phosphorus atom is losing 1 electron. There are 4 phosphorus atoms, so they will lose 4 electrons. And medium is basic, so in order to balance the charge we should write OH minus, since on the right hand side there is 4 negative charge, so 4 plus 8 negative charge, so we should write here 8 times of OH minus in aqueous state. So we have balanced the charge also. Now we'll count the number of atoms whose oxidation number is not changing. So here hydrogen and oxygen is the atom whose oxidation number is not changing. So oxygen on the left hand side is 8, on the right hand side is 8, hydrogen on the left hand side is 8 and right hand side is 8. So this is the balanced half cell reaction in which 4 electrons are participating. Now we'll balance the reduction reaction. In reduction reaction P4 molecule is converted into phosphine gas. So in phosphine gas phosphorus is in -3 oxidation state. First we balance phosphorus atom on both sides. So phosphorus on the left hand side from 0 is going to -3, means one phosphorus atom is taking 3 electrons. So 4 phosphorus atoms will take 12 electrons. In order to balance the charge in basic medium we should write OH minus, so 12 times of OH minus, charge is balanced. Then we'll check hydrogen and oxygen atoms whose oxidation number is not changing. On the right hand side we have 12 plus 12 4 hydrogen atoms. There is no hydrogen atom on the left hand side. This reaction is taking place in aqueous medium, so in order to balance hydrogen atoms on the left hand side we should write 12 times of H2O in liquid state. And now we can count for oxygen atom. Oxygen atom on the left hand side is 12, on the right hand side is 12. So this reaction is now balanced. In oxidation half cell only 4 electrons are participating, while in reduction half cell 12 electrons are participating. So we have to balance the number of electrons. In order to balance the number of electrons we should multiply the oxidation reaction by 3, and on adding the total number of electrons on the left hand side and right hand side will cancel out. So we can write that 3 phosphorus molecule and 1 phosphorus molecule. There are 4 phosphorus molecules on the left hand side. About the basic medium, in the first reaction oxidation reaction on the left hand side 24 OH minus ions are there. On the reduction reaction on right hand side 12 OH minus. So if we simplify we are getting 12 OH minus ions on the left hand side in aqueous state. Now on the right hand side we can write that 12 or 4 phosphine gas molecules are there and 12 hypophosphite ions are there, and in this way we should also look about the water molecule. Water molecule should be present on the left hand side, so 12 times of H2O in liquid state. So this is the balance reaction. So in overall balance reaction the number of electrons participating is 12. So if we want to calculate that what is the equivalent weight of phosphorus in this overall reaction, so we can use method 1. In method 1 we can say that in overall reaction 4 molecules of P4 is participating, and in overall reaction the number of electrons involved is 12. So for one molecule how many electrons will participate? So for one molecule we can write that 3 electrons is participating. Equivalent weight is equal to molecular weight divided by 3. This is by the first method where we calculate that the equivalent weight of the substance is the mass involved corresponding to 1 Faraday. So for 1 mole of electrons 3 moles of charge is participating. So that's why the equivalent weight of white phosphorus in this reaction is equal to molecular weight divided by. We can solve the same problem by using another method where we'll calculate the equivalent weight of white phosphorus participating in oxidation reaction and reduction reaction. So we know that in oxidation reaction white phosphorus is releasing 4 electrons. One molecule is releasing 4 electrons, so we can say that in oxidation reaction the equivalent weight of white phosphorus is equal to molecular weight divided by 4. Same way we can calculate how many electrons are participating in reduction reaction. We can see here for one molecule 12 electrons are participating, so we can write that the equivalent weight of white phosphorus for the reduction reaction is equal to molecular weight divided by 12. And if we want to get the net equivalent weight of white phosphorus participating in this reaction, we should add it. So we can take molar weight divided by 4 common. So that will be 1 plus 1 by 3. If we simplify, we are getting that is equal to molecular weight divided by 3. So we are getting the same answer by the first method as well as the second method. Before starting the disproportionation of sulfur, we have done an error in writing. So here we do the correction. This is 12 times of hypophosphite ion. So it is H2PO4. In place of PO4, it should be H2PO2. H2PO2 minus hypophosphite ion. Okay, now coming to disproportionation of sulfur in basic medium. So we know that when we are using sulfur in basic medium, it is converted into sulfide ion and thiosulfate ion. In case of thiosulfate ion, if we calculate what is the oxidation state of oxidation number of sulfur, so all the oxygen atoms here is in -2 oxidation state. So the average value of oxidation state is +2. If we calculate what is the oxidation state of 2 sulfur atom, then one sulfur atom is in -2 oxidation state and the other sulfur atom is in +6 oxidation state. And from experiment we are getting this proof that this sulfur is existing in -2 oxidation state, and that's why we are applying the concept that here the hybridization of sulfur is sp2 and the central sulfur atom is in sp3. So the percentage of S character in the terminal sulfur is more the value of S character, more electronegativity, and that's why we are saying that on breaking this double bond, this terminal sulfur will take all the shared electrons, so it has -2 oxidation state, while the central atom will lose the electron. So overall it is losing 6 electrons, so its oxidation state will be +6. So it's a very common question in exam about the oxidation state of 2 sulfur atom in thiosulfate ion. Coming to the balancing part, so this sulfur is participating in 2 reactions. One is oxidation. So first we'll write about oxidation. Sulfur from 0 oxidation state is moving to thiosulfate ion H2O3 2 minus ion, where the sulfur is present in +2 oxidation state from 0 to +2, and there are 8 sulfur atom. In order to balance that, we can write here 16 electrons. So we'll first balance those atoms whose oxidation number is changing. In order to balance sulfur, we should write like this. Then we balance the charge. In basic medium, the charge will balance on the right hand side 16 electrons and 8 negative charge, so total negative charge is 24. So we should write 24 OH minus ion on the left hand side. In order to balance hydrogen and oxygen, we should write 12 times of H2O on the right hand side. So we can count the number of sulfur atom balanced, 8 on left hand side, 8 on right hand side. Number of oxygen atoms on the left hand side is 24, on the right hand side is also 12 plus 12, 24. Charge is balanced. So overall reaction is balanced, hydrogen is balanced, right? So this is overall reaction. In this net cell reaction, the number of electrons participating is equal to 16. Same way we can balance the reduction part, S8 is converted into sulfide ion. First we balance the sulfur atoms. So 8, one sulfur atom is taking 2 electrons, so 8 will take 16 electrons, so select 16 electrons. In basic medium, there is no need to balance the charge because on both sides 16 negative and 16 negative, so charge is balanced and there is no other things to be balanced. So this is the balanced reaction. In the overall reaction, if we see an oxidation and reduction, 16 electrons are participating. So if we add, these electrons will cancel out and we can write that 2 times of S8 molecules in solid state plus 24 times of OH minus ion in aqueous state will form 4 times of thiosulfate ion H2O3 2 minus ion in aqueous state plus 8 times of sulfide ion in aqueous state plus 12 times of water molecule in liquid state. So from here, if we calculate what is the equivalent weight of sulfur participating in these 2 reactions, so we can write that method 1. We can write equivalent weight as, we'll calculate what is the overall molecules participating in the reaction. So 2 molecules of S8 is participating in the reaction. So corresponding to these 2 molecules, the number of electrons participating is 16. So we can say that for 1, the number of electrons participating will be be 8. So X factor is equal to 8. So we can write that the equivalent weight is equal to molar mass divided by 8. Molar mass acid molecule 8 into 32 divided by 8. So from here we can find out that the equivalent weight of sulfur participating in this reaction is 32. We can use method 2 again to calculate the equivalent weight of sulfur. So method 2 we can write that in the oxidation part what is the X factor and in reduction part what is the X factor. So in oxidation sulfur is losing 8 electrons, so we can write that the equivalent weight of sulfur molecule in oxidation part is equal to molecular mass, molecular weight divided by 16 electrons are participating, so we can write molecular weight divided by 16, molecular weight divided by 16. So from here if we want to write that what is the net equivalent weight, so net equivalent weight is equal to, if we add these two we are getting it is equal to molecular weight divided by 8, and we know that molecular weight of sulfur molecule is 8 times of 32 divided by 8, so that is equal to 32. So here if you go through your NCERT, in place of acid they have written sulfur. So when they will write sulfur, sulfur to sulfide ion or thiosulfate ion, H2O3 2 minus ion, you can calculate the number of electrons participating, right? So I have done by another method where in place of S we are using acid molecule and balancing, and from there the equivalent weight we are calculating by method 1, and method 2 we are getting the same answer, and that is equal to 32. So let us discuss the fourth reaction, disproportionation of halogens in basic medium. So except fluorine, because fluorine is a very good oxidizing agent, when fluorine is added to water it will oxidize water, right? So when chlorine, bromine, iodine is added to basic medium, they will disproportionate to form halide ion and hypohalide ion. Like chlorine undergoes disproportionation to form chloride ion and hypochlorite ion. So let us balance the disproportionation of chlorine. So here we can write that chlorine on disproportionation in basic medium is converted into chloride ion and hypochlorite ion. So for oxidation part, because here chlorine from 0 oxidation state, here chlorine is in -1 oxidation state, and this is the structure of hypochlorite ion. So oxygen is more electronegative, chlorine is present in +1 oxidation state, and oxygen is present in -2 oxidation state. Chlorine is changing its oxidation number. It exists in 3 different oxidation states, so there is disproportionation of chlorine atom. So we can write that in oxidation reaction chlorine molecule in gaseous state is converted into OCl minus ion in aqueous state by loss of electrons. So 0 to +1, so there are 2 chlorine atoms and there are 2 electrons involved. In basic medium we can balance the charge. On the left hand side we can add 4 times of OH minus, so charge is balanced. Now we have to balance hydrogen and oxygen atoms whose oxidation number is not changing. So in order to balance hydrogen, since the reaction is taking place in aqueous medium, we can add 2 water molecules. So this is the balance oxidation reaction. On the left hand side chlorine atoms are 2, hydrogen atoms are 4, and oxygen atoms are 4. On the right hand side also we are getting the same thing. For the reduction reaction we can write that chlorine in gaseous state will accept electrons to convert it into chloride ion. First we balance the chlorine atom whose oxidation number is changing, then they are accepting 2 electrons. Charge is balanced, there is no need to add OH minus because on the right hand side 2 negative, on the left hand side 2 negative, there is no other atom involved, so the reduction reaction is balanced. So if we see oxidation and reduction reaction, the number of electrons involved in these two reactions are 2. So if we add these 2 electrons will cancel out, so we can write that 2 molecules of chlorine in gaseous state plus 4 times of OH minus ion in aqueous state will form 2 times of hypochlorite ion plus 2 times of chloride ion plus 2 times of water molecule. So this is the balanced reaction. We can calculate the equivalent weight of chlorine gas by 2 methods. So if we are calculating the equivalent weight of chlorine by method 1, in overall balanced reaction 2 molecules are participating, and in overall reactions 2 electrons are participating. For 1 molecule the number of electrons involved will be 1. From here we can say that equivalent weight of chlorine is equal to molecular weight of chlorine, which is 71, divided by X factor 1. So we are getting equivalent weight will be 71. By method 2, we'll separate the two parts, we'll calculate the equivalent weight of the two parts separately. So chlorine participating in oxidation reaction, here chlorine when participating in oxidation reaction, it is losing, one molecule is losing 2 electrons, so X factor will be 2. When chlorine is participating in reduction, it is accepting, one molecule is accepting 2 electrons, so X factor will be 2. So for both oxidation and reduction reaction, we are getting the same X factor, so we can write that the equivalent weight in oxidation reaction is equal to molecular weight divided by 2, and same way the equivalent weight of chlorine molecule participating in reduction reaction is equal to molecular weight divided by 2. So if we add, we can write that what is the equivalent weight of chlorine in overall reaction. So the net equivalent weight is equal to molecular weight divided by 2, molecular weight divided by 2, so that is molecular weight divided by 1, which is equal to 71. So by method 1 and method 2, we are getting the same value of equivalent weight. So in the same way, we are going to complete this fifth disproportionation reaction about cyanogen gas. So first we are going through the structure of cyanogen gas. So this is the structure of cyanogen gas, where the oxidation state of carbon is, both carbon is in +3 oxidation state. In cyanide ion which is obtained from hydrogen cyanide. So if you remove hydrogen, carbon has -1 charge. So from here you can see that nitrogen is present in -3 and carbon is present in +2 oxidation state. In cyanate ion from cyanic acid, which is HOCN, this cyanate ion is obtained. So oxygen is present in -2, carbon is present in +4 and nitrogen is present in -3. So nitrogen is not changing its oxidation number, carbon is changing its oxidation number. It is moving from +3 to +2 and +4. So there is disproportionation of carbon atom in cyanogen gas in basic medium. Let us balance this reaction. When we are discussing balancing of this reaction, we can write that CN2 in gaseous state is converted into OCN minus, where carbon is going from +3 to +4. One carbon, first we balance the number of carbon atoms, so multiply right hand side by 2. So carbon plus from +3 is going to +4 by losing, one carbon is losing 1 electron, so 2 carbon atoms will lose 2 electrons. In basic medium, in order to balance the charge on the right hand side, 4 negative charge is there, so we'll add 4 times of OH minus. In order to balance hydrogen atom, there is no hydrogen atom on the right hand side, so we should write 2 times of H2O in liquid state, and we can count the number of hydrogen atoms, carbon atoms, nitrogen atoms and oxygen atoms. I think that the first half cell reaction is balanced. Same way we can calculate for reduction reaction. CN2 in gaseous state is converted into cyanide ion Cn minus, where carbon is present in +2 oxidation state. So one carbon atom plus from +3 oxidation state is moving to +2 by taking 1 electron. So first we balance the number of carbon atoms, then we can write on the left hand side there should be 2 electrons, so carbon from +3 is going to +2. Now we have to balance the charge. Charge is already balanced and nitrogen is balanced, so this reaction reduction half cell is balanced. Now in overall reaction of reduction and oxidation, same number of electrons are participating, so if we add, the number of electrons will cancel out. We can write that 2 molecules of cyanogen gas plus 4 times of OH minus ion will form 2 times of cyanate ions plus 2 times of cyanide ions plus 2 water molecules. So this is the overall balance reaction. So if we want to calculate what is the equivalent weight of cyanogen gas in overall reaction, we can say that in overall reaction 2 molecules are participating. For 2 molecules 2 electrons are there, so for 1 molecule we can write that in overall reaction one molecule is related to 1 electron, so X factor is 1, and we can write that equivalent weight is equal to molecular weight divided by 1. By the method 2, we'll calculate what is the equivalent weight of cyanogen gas in oxidation and reduction reaction. So in oxidation reaction, cyanogen gas is losing 2 electron, one molecule is losing 2 electrons, so its X factor will be 2. In reduction, one molecule is taking 2 electrons, so X factor will be 2. So from here I can write directly that equivalent weight net is equal to equivalent weight in oxidation, that is molar mass divided by 2, and reduction, that is again molar mass divided by 2. So if we add and simplify, we are getting that is equal to molar mass divided by 1. So either it is method 1 or method 2, we are getting the X factor in overall reaction, disproportionation reaction, as 1. So equivalent weight is equal to molecular weight. So this is our last example given in NCERT. We have to balance disproportionation of manganese plus 3 ion in acidic medium, and in acidic medium manganese plus 3 ion is converted into manganese plus 2 ion and MnO2. MnO2 is insoluble in water. So in order to balance the oxidation half cell reaction, we should write that manganese in plus 3 oxidation state is converted into MnO2. Since manganese atom is changing its oxidation number from plus 3 to plus 4, it is losing one electron in acidic medium. In order to balance the charge, on the left hand side there are 3 positive charge, so we have to write 4H plus ion on the right hand side. In order to balance hydrogen and oxygen, we should write 2 molecules of water on the left hand side. So oxygen, hydrogen, manganese, and charge is balanced. So for the reduction reaction, same way we can write that manganese plus 3 will accept 1 electron to form manganese plus 2. The atoms whose oxidation number is changing is balanced, charge is balanced, there is no other atom whose oxidation number is changing, so we have balanced the reduction part. So in overall reaction, if we add, the number of electrons are equal, they will cancel out. We can write that 2 ions of manganese plus 3 plus 2 water molecule H2 in liquid state is converted into MnO2 solid, plus manganese plus 2 ion in aqueous state plus 4 times of H plus ion in aqueous state. So this is the overall reaction. In this overall reaction, if we calculate what is the equivalent mass, so 2 particles of manganese ions are there. For 2 mole particle, 1 mole of electron is participating, 1 mole of electrons is participating. So we can say that for 1 particle, the number of electrons participating is equal to half. So X factor is equal to half. So from here we can write that what is the equivalent weight. Equivalent weight is equal to molecular weight divided by half. In this particular reaction, the equivalent weight is 2 times of molecular weight. By the second method we can find out. So we'll calculate the equivalent weight of manganese plus 3 ion in oxidation and reduction part. In oxidation part, manganese is moving from plus 3 to plus 4, okay, so 1 electron. So we can say that equivalent weight in oxidation part is equal to molecular weight divided by X factor. X factor is 1. In reduction also it is taking 1 electron, so we can write that equivalent weight in reduction part is equal to molecular weight divided by 1. So if we add these two reactions, in overall reaction we can find out what is the net equivalent weight of manganese plus 3 ions. So the net equivalent weight of manganese plus 3 ion is equal to 2 times of molecular weight. So we are getting the same answer by method 1 and method 2. So I hope that now you know how to balance a disproportionation reaction and how to calculate the equivalent mass of a chemical species participating in disproportionation reaction. So let us solve the last question given in NCERT about this topic. So let me read the question first. Refer to the periodic table given in your book and now answer the following questions. Select the possible non-metals that can show disproportionation reaction. Select 3 metals that can show disproportionation reaction. So the first condition for disproportionation reaction is the element must present in at least 3 different oxidation state, means it can show variable oxidation state. So here we have discussed about the non-metals. In basic medium, if phosphorus, white phosphorus is there, it will disproportionate to give phosphine gas PH3 and hypophosphite ion HPO H2PO2 minus hypophosphite ion. So phosphorus is a non-metal which can undergo disproportionation. Same way we have discussed that sulfur molecule, when undergoing disproportionation reaction, it will form sulfide ion, and thiosulfate ion H2O3 2 minus ion in aqueous state. The same reaction in NCERT, if you see, they have written as solid state is converted into sulfide ion plus thiosulfate ion. There is no problem while balancing and calculating equivalent weight by using this reaction or that reaction. So sulfur undergoes disproportionation reaction. Again, all the halogens except fluorine, chlorine, bromine and iodine will undergo disproportionation reaction to form halide ion and hypohalide ion, HCl minus or OBr minus or OI minus, right? So halide ion and hypohalide ion. For metals, when we are discussing that which metals can undergo disproportionation reactions, so when we are talking about metals, the metals which have multiple oxidation state, more than one oxidation state, like alkali metal, alkaline earth metals, aluminum, they cannot undergo disproportionation reaction. Like copper can undergo disproportionation reaction because copper can exist in copper plus 1, copper plus 2 oxidation states. Similarly, thallium plus 1, thallium plus 3, thallium plus 1 undergoes disproportionation, copper plus 1 undergoes disproportionation reaction. Same way we have discussed about manganese. When manganese is present in plus 3 oxidation state, it is converted into plus 2 oxidation state and MnO2. So manganese, it is metal ion which is going disproportionation reaction, but yes, manganese metal ion can go undergo disproportionation reaction. Or we can say that mercury can go. Mercury is present in plus 1 oxidation state as Hg22 plus. It can converted into Hg2 plus and mercury. So mercury can undergo disproportionation reaction. So the point is, the metals which can show variable oxidation state can undergo disproportionation reaction. So hope this video is useful to you. If it is, please like and subscribe, and if it is useful, please write so that we can give you more videos based on JEE Mains exam. Thank you.